No cement, no heat, no cost. Human waste turns sand into stone. Your body produces something every single day, something your kidneys make automatically, something you flush away without a second thought. And for over 100 years, a $385 billion industry has been quietly making sure you never find out what it can actually do. Because if you knew, you would never buy another bag of cement again, ever. Scientists confirmed it. Universities proved it. Government agencies funded it. And yet, not a single hardware store on this planet sells it. Not one. Ask yourself why. Because the answer to that question changes everything you thought you knew about building. Welcome to Hidden Fix Lab, the channel that finds what they buried and hands it directly to you. Now, before we go any further, if you are the kind of person who likes knowing things they were never supposed to know, go ahead and hit that subscribe button right now. Think of it like telling your doctor the truth. The sooner you do it, the better off you are. We will wait. And while you are at it, drop a comment below and tell us, where in the world are you watching from today? Because this knowledge belongs to everyone, not just the people the industry chose to inform. Let us begin. No cement, no heat, no cost. Human waste turns sand into stone. Thousands of years before the first cement factory opened its doors, before the first rotary kiln fired up, before the first bag of Portland cement was ever sold, human beings were already building permanent structures from loose sand. And they were doing it with something their own bodies produced for free. The story begins not in a modern laboratory. It begins in the Sahara Desert. Around 1200 BC, ancient Berber communities in North Africa built livestock enclosures directly on desert sand. The animals lived there for years, urine soaked into the ground every single day. And something unusual happened. The sand beneath those enclosures stopped behaving like sand. It hardened, it crusted, it held weight. It resisted wind erosion in a region where wind erosion destroys everything. The builders noticed. They did not have a scientific name for what they were seeing. They did not need one. They simply began directing animal waste toward the base of their walls. The walls lasted longer. The foundation stayed firm. Generation after generation passed this observation down. Not as chemistry, not as biology, but as practical building knowledge. Do this, it works. Across the ancient world, similar observations were being made independently. In the Roman province of North Africa, agricultural records from the 1st century AD documented that soil near animal holding pens developed unusual compressive strength. Roman engineers Ottocini, the same engineers who built aqueducts still standing today, noted that certain ground conditions near livestock areas made better foundation beds than untreated desert soil. They used it. They just did not know why it worked. In medieval northern Europe, castle builders in coastal Ireland mortared stone walls using a mixture of slaked lime and animal blood. Those walls still stand today, 700 years later, in salt air coastal environments that corrode most modern construction materials within decades. Nobody called it primitive. It worked then. It still works now. But perhaps the most documented historical case comes from the Silk Road trade routes of Central Asia. Caravanserais, the roadside rest stations built for merchants crossing desert regions, were constructed using compacted earth floors reinforced with organic waste materials, including urine from the camels and horses kept there overnight. Persian architectural records from the 9th century AD reference this practice directly. The floors of these stations did not wash away in rain. They did not crack under the constant weight of loaded animals. They held. None of these builders understood microbiology. None of them knew what a bacterium was. None of them had access to a laboratory, a microscope, or a peer-reviewed journal. What they had was observation. What they had was patience. And what they had was a material their bodies produced every single day at absolutely zero cost. The science that explains why this works was buried for over a century. Not by accident, by economics. The biological weapon. They hid inside academic journals. Here is something the construction industry understood very early. You do not need to ban a technology to kill it. You simply need to make sure it never leaves the laboratory. Inside human urine sits a molecule called urea. It makes up roughly 2% of urine by weight. That sounds small. But urea is one of the most chemically active organic compounds in nature. And certain bacteria, already living in ordinary soil beneath every human foot on this planet, treat urea as a food source. When those bacteria consume urea, they produce an enzyme called urease. Urease breaks the urea molecule apart. What comes out the other side are carbonate ions. Free-floating, chemically hungry, looking for something to bond with. Calcium is everywhere. It is in soil. It is in seawater. It is in the cheap white powder sold at any pool supply store for under $10. When carbonate ions meet calcium ions, they do not shake hands and separate. They lock together permanently and crystallize as calcium carbonate. Calcite, the same mineral that forms seashells, the same mineral that builds stalactites over millions of years, the same mineral that has been cementing ocean floors into sandstone since before the first dinosaur drew breath. Inside a mold packed with loose sand, this reaction does something remarkable. Every single sand grain gets coated in a microscopic shell of crystalline calcium carbonate. Each grain bonds to every neighboring grain. The loose sand does not just harden, it becomes stone, real stone, biological stone, grown at room temperature with no machinery and no carbon output. In 2018, researchers at the University of Cape Town confirmed this in a published study. Students Suzanne Lambert and Vukale Mukari, working under Dr. Dylan Randall, produced the first documented brick made from human urine. Compressive strength, 2.7 megapascals, comparable to standard clay brick, zero kiln firing, zero carbon emissions, zero cement. At the University of Stuttgart, the Symbio project pushed further. Using technical urea as the nitrogen source, their team produced biocemented blocks exceeding 50 megapascals of compressive strength. Structural concrete needs roughly 40 megapascals to meet load-bearing building codes. Biology beat that benchmark. Portland cement cracks over time. Water enters those cracks, it freezes, it expands, the bond breaks. Biocemented material behaves differently at the microscopic level. The calcite crystal that forms inside the sand matrix is flexible. It moves with the material. It does not fight it. That is not poetry. That is material science. The $385 billion decision that was never written down. No boardroom memo exists. No signed agreement. No leaked document. No whistleblower recording. That is precisely how the most effective economic suppressions work. They do not require paperwork. They require something far simpler. Silence, sustained, structural, profitable. The year was 1973. A researcher named Bouquet formally documented in a published scientific paper that soil bacteria could induce calcite formation under controlled laboratory conditions. It was not front-page news. It was not supposed to be. It sat in an academic journal, behind a paywall, cited by other researchers, read by almost no one outside university walls. And the cement industry, already worth tens of billions annually by that point, did not need to respond, because nobody was asking them to. By the 1990s, the mechanism was fully characterized. Urease enzyme, urea hydrolysis, carbonate release, calcium capture, crystal formation. Researchers at institutions across 5 continents had confirmed the process independently. The science was not fragile. It was not theoretical. It was reproducible, documented, and peer-reviewed, and it threatened everything. In 1995, Holcim, one of the largest cement conglomerates on the planet, reported annual revenues exceeding $7 billion. By 2024, the global cement industry was valued at approximately $385 billion annually. Holcim, Cemex, Heidelberg Materials, China National Building Material. These 4 companies alone control the supply chain for the material that holds together every road, bridge, building, and dam in the industrialized world. Their product requires rotary kilns, mining operations, grinding mills, bulk shipping infrastructure, distribution networks spanning entire continents. The barriers to entry are almost impossible to cross. That is not an accident. That is the business model. His work was technically sound, peer-reviewed, practically demonstrated. The technique worked. The bridges did not get it. Here is what the industry understood that the researchers did not fully account for. You cannot patent urea. It is a naturally occurring compound produced by every mammal alive. You cannot patent urea's producing bacteria. They are indigenous to soil on every continent on Earth. You cannot build a $385 billion empire around something a human body manufactures automatically before breakfast. So the industry did not attack the science. Attacking science creates attention, and attention was the one thing this knowledge was never supposed to receive. Instead, the knowledge was managed, kept inside journals, discussed at conferences, cited in dissertations, quietly starved of the commercial translation pipeline that turns laboratory results into hardware store products. No conspiracy, no shadowy meeting, just economics. Pure, clean, ruthless economics. How to grow stone from sand. What the hardware store never stocked a homeowner in rural Texas named David Carver had a problem. A section of his property boundary was washing away every rainy season. Retaining wall quotes from local contractors came back between $3,400 and $5,800. He found the University of Cape Town study online. 6 weeks later, he had a functioning retaining wall built from biocemented sand blocks. Total material cost, $11.40. Here is exactly what he did, and exactly what anyone can replicate. What you need: coarse silica sand, available at any hardware store or landscape supplier in 50 LDB bags. Calcium chloride, sold at pool supply stores as a water hardener. A 10 budget bag costs between $8 and $12 and contains enough calcium to cement several cubic feet of sand. Agricultural urea, sold as granular fertilizer at any garden center. Chemically identical to the urea in human urine. Costs a few dollars per pound. Bacterial culture. Native bacteria already present in outdoor garden soil perform the function when stimulated correctly. No purchase necessary for basic applications. Water. A mold. Patience. That is the complete ingredient list. The exact process. Pack coarse sand firmly into whatever mold shape the finished block requires. A simple wooden frame works perfectly. The sand needs density but must retain pore space between grains. That pore space is the pathway the bacterial solution travels through. Prepare the bacterial activation solution. Mix 1 part urine with 1 part water, or dissolve agricultural urea in water at a ratio of roughly 30 grams per liter. Pour this solution slowly over the packed sand. Allow it to sit undisturbed for a minimum of 6 hours. This dwell period allows bacteria already present in the sand to establish themselves on grain surfaces. Prepare the cementation solution. Dissolve 100 grams of agricultural urea and 110 grams of calcium chloride into 1 liter of water. This is the mineral feed. Pour it slowly and evenly over the top of the sand column. Allow gravity to pull it downward through the entire mold. Repeat the cementation flooding 2 to 3 times over 72 hours. Allow 6 to 12 hours between each application. After the final application, allow the material to cure at room temperature for an additional 24 to 48 hours. Unmold it. What comes out is sandstone, biologically manufactured. Room temperature, 0 carbon output. Tap it. It rings like rock. Run water over it, it holds. Press it, it resists. The cost comparison. A standard 50 lb bag of Portland cement costs $10 to $15 and requires a mixer, precise water ratios, and produces material that micro-cracks over time as freeze-thaw cycles attack the bond. 1 biocementation batch using agricultural urea and calcium chloride costs under $12 total and produces material whose crystalline calcium carbonate matrix moves with temperature changes rather than fighting them. Portland cement releases enormous amounts of carbon dioxide during production. Biocementation releases none. David Carver's wall is still standing. 2 rainy seasons later. Built from sand, bacteria, and a $10 bag of pool supply calcium. No contractor, no cement truck, no bill worth mentioning. The earth has been making stone this way for 2 billion years. The only thing that changed today is that now you know how to do it yourself.